Assalamu alaikum dear students. In this series of learning C programming, we are discussing dynamic memory allocation in C. In the previous video, we have discussed what is dynamic memory allocation, how static memory allocation is different from the dynamic memory allocation, what are the disadvantages of the static memory allocation, or we can say why dynamic memory allocation. Everything regarding the dynamic memory allocation as the introduction part. You can say the introduction part of the dynamic memory allocation have been thoroughly discussed in the previous video. And in today's video, we are going to discuss the malloc function. As I have told you in the previous video that there are three functions which are used to allocate the memory dynamically. Those functions are the malloc function, calloc function, or the alloc function. And one by one, each function will be discussed in coming videos, and in today's video we will discuss what is malloc function and what is the syntax of malloc function and how malloc function works, how, or I can say how we can allocate, how the memory is going to be allocated dynamically using the malloc function. So our today's topic is malloc function. Malloc means, as the full form of malloc, full form of malloc is memory allocation. Memory allocation. Generally, this malloc function is used to allocate the memory for the structures. We can use malloc function for other purposes as well, but general use of malloc function is to allocate the memory for structures, as we use the calloc function for allocating the memory to arrays. In the same way, we can use this malloc function for allocating the memory to the structure dynamically. We can use this malloc because this malloc function, in order to allocate the dynamic memory dynamically, we use pointers. As we have already told, I have already told you in the previous video that the pointer is used. We cannot allocate memory dynamically directly, but in order to allocate memory dynamically, we use the pointer. So without pointer, it is not possible to allocate the memory dynamically. So we can say that it is one of the most important application of pointer to allocate the memory dynamically to the data structures. I can say to structures, to arrays, or to any other program. So pointers are very important. Pointers are mandatory for allocating the memory allocating memory dynamically. So here, first of all, here I will write the syntax of this malloc function. What is the syntax of malloc function? Void pointer malloc size underscore t size, and that is what does this here. This size underscore t means unsigned value. That means it can take arguments. It can take either 0 or positive value. We cannot show here. We cannot request for a negative value because memory cannot be a negative. That means the size of the memory, whatsoever you want to allocate memory, that must be in a positive value. For example, here if I write here, similarly, for example, I write here 3. That means 3 bytes of the memory will be allocated by the memory manager for this malloc function. That means 3 bytes of the memory will be allocated by the memory manager for this program. From the heap, as I have already told you in the previous video, that whenever a memory is going to allocate it to a program, the memory layout, which I have discussed in the previous video, that is, some memory is reserved for this code and text, some is used for global and static variables, and mainframe from state, and this is for heap. Actually, whenever a memory is allocated dynamically, that is going to be allocated from this heap portion, because a heap is a long, we can say a block of memory. It's a long block of memory, and whenever memory is going to be allocated dynamically, it is going to be allocated from this heap portion. So, malloc function allocates the memory to the program dynamically from this heap portion. So, here we can write several syntax, just void malloc. Generally, we don't write here these fixed values. We write here simply there, for example, size of operator. We use size of operator. That means size of, for example, I will write here int. That is it. 3. The syntax of this malloc function is size of operator. Actually, I have requested here that I want to store 3 elements. That means I want the memory for 3 elements. So 3 and size of int. We know that size of int is 4 or 2 bytes. That means some compilers allocates 4 bytes of the memory for the integer, and some that can allocate 2 bytes of the memory for the integer. That means total of 3 into 4, that is 12. 12 bytes of memory will be allocated by the memory manager dynamically for this malloc. And this is size operator, which is actually the size of operator into how many elements you want to store. For example, if I, instead of 3, if I want to store 5 elements, it will allocate as 5 into 4. I assume that I am working in a machine which allocates 4 bytes to an integer. That means 4 into 5, 20 bytes of the memory will be allocated. That means a complete block of 20 bytes will be allocated for this, by this line, by the memory manager for the program dynamically. So, and I have also told you that we use the pointers in order to access the memory heap here, memory, or in order to allocate the memory dynamically, we use the pointers. This malloc function returns a void pointer. Now the question is why it return the void pointer? Because at the time of this allocation, when we, for example, here I am requesting for 5 or 8 bytes of memory. For example, suppose I am requesting for 8 bytes of the memory. So a complete block of 8 bytes will be allocated by the memory manager for this malloc function, for the program, by this malloc function dynamically. That means a complete block will be allocated. But at this junction, at this time, malloc does not know what type of data I want to store it. What type of the data, whether I want to store in the program, where in this memory, the integer data, the float data, or the character data. What type of data? At the time of this allocation, the malloc does not know what type of data the user is going to be stored in this memory allocated dynamically. So, in order to avoid any inconvenience, the malloc function returns the void pointer. That means the returning type of this malloc function is void. As we have already discussed it in the pointers, the void pointer is the generic pointer. The void pointer is the generic pointer. We can typecast this void pointer to any other pointer. We can typecast it into float, we can typecast it into char, we can typecast it into integer according to our need or according to the programming need. That's the reason that the malloc function returns the y pointer. And we know we have a funda of a typecasting, we can typecast it into any other data type as well, any other type of pointer as well. For example, we can typecast it into float, we can typecast it into character, we can typecast it into integer according to the programming need. So for example, here, for example, three into size of simply int. By execution of this line, here, what is going, for example, I want the memory manager will allocate me the 3 into size of int. We know it is 4 bytes, that is 12 bytes of memory will be allocated by the memory manager dynamically. That is a complete block of 12 bytes, where I am going to store the 3 integers. That means, for example, this is for first, this is second. Where I am going to store the 3 integers, that is a complete block of, for example, 12 bytes will be allocated by the memory manager from this heap portion. As I have told you that the memory at a runtime or dynamically is allocated from this heap portion. So from the heap portion, a complete 12 bytes of the memory will be allocated by the memory manager, where I am going to store the 3 integer values, because here I am requesting for size of int. We know that size of int is 4 bytes in some machines, and in some machines it is only 2 bytes. For example, then I want to store integer, then I want typecast. How I can typecast it? The question is, actually this, the malloc function returns the y pointer, and I want to typecast it into the integer. First, for example, this is our ptr pointer. Ptr is the pointer, name of the pointer, which is going to store the address of the integer variable, integer data type. Address of the variable whose data type is integer. You can see ptr, this equation shows that ptr is the name of the pointer, which stores the address of the variable whose data type is integer. And we know that, for example, here I will write it. For example, 200 is the base address of this, 204 will be the base address of this, and 208 will be the base address of this location. If you return, here I have declared a pointer ptr, and I want to type how I am going to typecasting. In case simply here at void I can write int ptr malloc 3 into size of int equal to ptr. This is a typecasting. Here I have typecasted this y pointer into an integer. Now this ptr stores the address of the variable, base address of this variable. That means ptr, this is the ptr. Ptr actually the memory for this ptr is allocated from the stack, not from the heap. Now this ptr contains the address of first byte of the memory allocated. That is address of this block. So ptr, now it returns the pointer address ptr, which is going to be stored in ptr. It returns the address of the first byte. Here the address of the first byte of the memory allocated dynamically by using this malloc function is 200. That is going to be stored in ptr. Now using this ptr, we can access the elements of this block. We can access the elements of stored at this memory. So we can insert the elements that here, and we can also read the elements stored at these locations by using this PTR. Thus, that's the reason that pointers are used to access the memory allocated dynamically. We cannot access directly the memory allocated dynamically. For that purpose, we use the pointer. Normally, generally, actually, the malloc function returns the void pointer, which I have told you. The return type of the malloc function is void, but we can typecast any other type, because void pointer is generic pointer, which we have already discussed in the videos, which already I declared in the pointer series. So here, this PTR now contains the address of the first byte. Here, the address of the first byte 200, second of the 201, 202, 200 and 204 here. So it contains the address of the first byte, that is the 200. Okay, I now hope that you have understood that what is malloc function. Actually, malloc function is nothing. Malloc function is a function which is used to allocate the memory dynamically. And the memory which is allocated by using the malloc function or dynamically is going to be allocated from the heap portion, not from the stack or a global or any other portion. Okay, and the malloc function generally, the return type of the malloc function is void. We can typecast this pointer, void pointer, to any other pointer according to the programming need. We can typecast it into integer, we can typecast it into float, we can typecast it into any other data type as well. So here, now I am going to write a program, and with the help of that program, we will discuss the working of this malloc function. Yes, one thing about the malloc is that if the elements of these locations are not initialized, by default, it takes some garbage value. By default, the location, these locations contain some garbage value. It may be a negative value, it may be a positive value, it can be anything. By default, if it remains uninitialized, that means uninitialized memory contains some garbage value when allocated by using the malloc function dynamically. Okay, take care. Now I am going to write a program, and with the help of that program, we will discuss it is working. Simply here, void man int n pointer ptr and I printf enter limit second percentage d address of n printf. First I'm going to ptr equal to malloc size of int printf enter values for I equal to 0, I less than n, I plus plus, second percentage d ptr plus I into size printf percentage printf for I equal to 0, I less than n, I plus plus, printf percentage d ptr plus I into size 3 ptr, and that is it. Here I have write down a program. With the help of this small program, we will discuss the working of the malloc function. Here I have declared three variables, and first one is an, and this is the pointer ptr and I for loops. Enter the limit. For example, here the user wants the memory for three elements of type integer, of size integer. That means 3, n is 3. Here I can write here only n. For example, here 1, 2 and 3, n is 3. That means 3 into size of it is 4. 12 bytes of the memory will be allocated dynamically by the memory manager for this program. Printf enter values. Then I want to print the values. Here it will return the address which is going to be stored in the PTR. That means PTR base address. Here the base address of this memory is 2100. That is going to be stored in here at PTR. Now this PTR contains 200. Enter the values. For I equal to 0, I is 0, I less than n, yes 0 less than n. That means this condition is true. When condition is true, it will enter into the loop. We have already discussed the loops. Second person be PTR plus I into size. What is PTR? PTR is 200. Take care. Plus I is 0. And what is size of integer? That is 4. 4 into 0 equal to 0. 0 plus 200 equal to 200. That means the element is going to be stored at the 200 location. That means here, for example, I have stored here 15. Okay. And I plus plus, I will become 1. I less than n. Yes, 1 is less than n. Condition is true. Second percentage PTR is 200. Plus I. What is I? At this moment, I is 1. And what is the size of it? Size of it is 4. That means 200 plus 4 into 1. 4 into 1, 4. That's 204. Now the pointer will point to the next location. 203 second. This location, 204. And for example, here I am storing 20. Now I plus plus, it will become 2. I is less than n. Yes, 2 is less than n. Condition is true because n is 3 at the moment. Condition is true. Second percentage PTR. Now 200 plus 4. I is 2. Size is 4. That means 200 plus 4 to the 8. 208. Now this pointer will point to this 208 location. And here I am going to insert another element, that is 30. I plus plus, it will become 3. Okay. Now condition again, condition will get checked. I less than n, less than 3. No, condition is false. The control will go outside the body of the loop here. For I equal to 0. Now this for loop was for inserting the elements at the locations at the memory allocated dynamically, and this second for loop is for printing those elements, for displaying those elements. For I equal to 0. Now again I equal to 0, I less than n, 0 less than n, print a percentage. Here this asterisk PTR means the value at address, because here this asterisk acts as an indirection operator. Here this asterisk acts as pointer, but here it acts as an indirection operator. What is the purpose of indirection operator? What is the working of indirection operator? Indirection operator returns the value at the address. Here, what is PTR? PTR is 200. What is the value at 200? First, it will get calculated here. 200 plus I is 0, size is 4, That means 4 into 0 equal to 0. 0 plus 200 is 0. And what is the value at 0 at this 200 location? That is 15. That means 15 will get printed by this. And now I plus plus, it will become 1. I less than n, 1 is less than 3, condition is true. Print up. Here again it will get calculated. PTR is 200 again. 200 plus I. Now I is 1. Size is 4. That means 4 into 1, 4. 200 plus 4 equal 204. Now it will return the value at this address, 204, that is 20. Now 20 will get printed. Again, I plus plus, it will become 2. I less than n, 2 is less than n, that 3 condition is true. It will enter into the body. Print a percentage. Here again it will get calculated. PTR is 200. 200 plus. Now I is 2. That means 4 into 2 equal to 8. That is 208. That means this location. And the value at 208 is 30. That will get printed by this instruction. That means third, 30 will get printed. I plus plus, it will become 3. 3 is less than n. 3 n. And is 3 is less than 3. No condition is false. And body will go outside of this whole loop. And after that, here I have written this free function. The working of the purpose of free function is to deallocate the memory allocated by dynamically. Here PTR is the memory, this PTR point, this memory will get deallocated. It will get deallocated. So in this way, it is a working of the memory is going to be allocated and deallocated dynamically. I hope now you have understood what is malloc, why do we use malloc, what the syntax of malloc, what malloc function returns, and how to use the malloc function in the program. Hope now you have understood these things well. And inshallah in the next video we are going to discuss one more dynamic memory allocation function, that is the malloc function. That will be discussed in the coming video. Till the next video, take care. Bye bye.